My dear colleagues, time is running out. The Empire is amplifying its attacks against our bases, and we are having great difficulty rescuing the survivors. Which is why the High Council of the Resistance is asking us to develop a software that will help us to assemble rescue fleets with the starships we have at our disposal. I explain you what we need to develop here. Assuming we have 5 survivors to rescue, our new product should search for the starships we have in our existing inventory named Swappy. Swappy is a web service developed with REST. And in this inventory, we'll take a particular look to the passengers' capacity of the starships, because we want to filter out the starships that cannot transport any passengers, such as here the X-Wing. And then we will apply on the eligible starships a very complex algorithm that will help us to assemble rescue fleets. This algorithm will be based on AI. It means it will have more than 3 ifs in the code. So here, I will try to popularize this algorithm for you. So you can see that the Millennium Falcon has a 6 passengers capacity, which is clearly enough to rescue these survivors. So it will be the only ship taking part of that rescue fleet mission. So we don't have time to lose, and we need to choose right now the architecture we'll put in place to develop this software. And I'm proposing you to apply this classic layered architecture with a controller layer, depending on the service layer, depending on the persistence layer. Who agrees with that? Really? But that was a trap. Did you ever take a look at the title of the talk? It was just to see if any Empire spies were hiding among our ranks. Because we won't use that architecture, although the fact that it can be really helpful and useful, it tends to age poorly with time. But before showing you why, I would like to ask you one simple question. In that kind of architecture, where are you supposed to find the business logic? Service, yes, it's true. But I also heard something else. Everywhere. Yeah. With time, you will find it everywhere because this architecture has some flaws. It doesn't properly isolate one layer from the other, so you have that kind of business logic in the controller, but also in your data access objects inside the persistence layer. And when you have business logic there, having unit tests will be quite complicated to do, since you might need some integration tests because you have here GPA or something like that, or perhaps you even need an external database. And if you move from one database technology to another one, from SQL to NoSQL, for example, it's quite sure that you will lose that part of the business logic. So here we have too many coupling. And you know what? The most wicked engineer of the Empire go as far as putting the business logic in the stored procedures. I'm not lying, directly in the database. And I can see people having some kind of post-traumatic stress disorder symptoms here. So you know what I mean? When you need to debug that kind of things. But we don't have only problems regarding business logic, because you might think it's quite OK regarding technical concerns. For example, that everything related to database will be inside the persistence layer, but you will find it also everywhere, because you might find it everywhere, because here this is simple cascading architecture. From the controller, you can see everything. Who have ever seen people doing SQL requests in the controller? Yeah, quite a few, right? It's not something that you never see. But usually, you also see that kind of class in a Spring Boot application, for example. So here, we have an exercise class, and you will see that it's annotated with GPA annotation. So from the service layer, we're shaping the database. And here, this is a SQL database, right? Which is a normal form, if you know that. And you also see that here, there is some JSON property annotation. So we also shape the way the controller should serialize that object on the network. So everything is coupled here in the service layer. So here, if you want to change your database technology, you move from SQL to MongoDB, and you become from a normal form to a document form. It's quite sure that you will have to change the shape of your service layer, and it may have an impact on the controller layer as well. Furthermore, here, you will see that sometimes some fields are annotated with @join table here. It means that behind the scene, if you want here to retrieve the tags, it will do a join in a SQL request. So it also means here that this data will not be there if you want to do a unit test. So once again, too many coupling. There is also one problem with the structuring frameworks we like to use, such as Jfokus and Spring Boot, because they are really helpful, but we tend to put it everywhere, even in places where they shouldn't be. Because if you couple it with your business logic, and then you upgrade that framework to a breaking change version, meaning a minor version of Spring, you may have functional regression, although you didn't touch at all the business logic, right? Doesn't make sense. And you have to think that one day your backend will become legacy. So let's say there's a version of you 15 years ago, for the people who were already developer at that time, you developed a backend using EGB3, because that was the main thing at that time. Maybe it was 2 at that time, but anyway. And now, let's say it's working well, and now you have to take it back, but EGB3 is no longer supported, right? So maybe you want to modernize it and move that to Spring Boot or Jfokus. But the business logic is working well. Can you just extract it and put it in a Spring Boot skeleton? You don't think it works? No, you will have to recode everything, right? Because that business logic will be EGB shaped. Does it make sense? Once again, since business logic is business logic, it's just algorithm, it should be portable, right? And because this is a simple cascading architecture, you will have some kind of chain reaction when you have errors. For example, if you have compilation error in the persistence layer, your service layer will no longer compile as well as a controller layer. So as you can see here, couplings here mean fragility, and this is one of the flaws of this architecture. And today we'll see how to go over it by discovering another kind of architecture, which is the hexagonal architecture. The name was coined by Alistair Coburn in 2001, and you will see this is a pattern for managing software complexity and technical depth, but I will talk about that a bit later. So the philosophy in the hexagonal architecture is that we want to sanctify the business logic, since we think this is the most important thing in your application. It is actually what brings value to your users, but also what is paying your salary, right? Because that's the business logic of your company. So we don't want that to be everywhere. We'll take all this business logic and we put it in a single place. That way, it will be easier to write tests that only has one concern, functional tests. And then we'll rename that domain instead of service. And maybe now you have one question for me. Julien, what's the difference between that domain layer and that service layer? Can't you see it? You have it? The name, obviously. No, in fact, there's more than that. The service layer we used to have here has two responsibilities. First, the business logic, I told you already, but also it has to orchestrate deeper technical layers of your application, such as the persistence or web service clients. And this is something we don't want in hexagonal architecture, because we want that business logic to last long and not being coupled with technical concern, to be agnostic, right? So instead of having here the domain depending on a persistence layer, we'll do the opposite. This is the persistence layer that will depend on the domain, and that domain becomes an hexagon. So why it's called the hexagon? Looks like that if you look it in a way, I don't remember why, but maybe just like the shape, but anyway. But that way, in fact, your domain will be isolated. Your business logic is isolated, it doesn't know anything regarding technical concern. So it also means that you won't have any frameworks inside that hexagon. Frameworks will be outside, in the infrastructure. It will deal with the controller and the persistence layer and the other technical layers. In a domain, you don't have to reinvent the wheel again. You can use here libraries. It's totally OK. But make sure that if you use some libraries, it should be quite easy to get rid of without having to recode all the domains. Otherwise, you might not have the good fit here, since we want that business logic to last long. And here, we have done something really interesting, because we just have a better management of software complexity. So if you remember software complexity theory, in the domain here, you have what we call the essential complexity. This is the reason for being of your software, mainly the business logic. This is why you have built that software. And outside, we have the mandatory complexity, which is everything technical, mandatory to make that business logic happen. Because you don't put users in front of algorithm, right? They cannot execute it just by looking at the code. So you need controller persistence, UI, and stuff like that. And the thing is, this is better because we have less coupling. So if you're coupling essential and mandatory complexity, you create what we call accidental complexity. That sometimes you call that also technical debt. But here, this is in a way, we are doing a loss coupling so we can have that business logic last longer. So to see how it's working internally, we'll do a deeper look here. And you will see that in the hexagon, there is two subparts. There is the API and the SPI. API stands for Application Program Interfaces. And those are a set of interfaces that will help the outside of the domain to interact with it, to trigger features, right? So it's mainly for controllers, right? And so those things are the contracts of your features. And it depends only on domain objects, which is quite interesting, because it means that no type from here, the left side, can enter and pollute the domain. So that business logic will be still technological agnostic. So it means that if you have any representation of REST resources, it will remain here in the controller. If you have frameworks, it will be there. Jackson annotation will be there. Nothing inside the domain. So then, if you need to have another way to interact with your application, for example, a message broker, it will be easier because you just have here to create that kind of module, a RabbitMQ receiver, calling that interface without having to change the domain, because it's not a resource-based domain, right? Because here, if you do RabbitMQ, you have more message-based interactions. And then, your feature needs data from outside, usually, from the persistence or external web service. And that's why we have here the service providing interfaces. It will help that domain to interact with the outside. It defines its own contract to go outside. That way, these interfaces here depends only on domain objects, so nothing from the right side here can pollute that domain. So everything related to SQL requests, DAOs, entity manager, and so on will remain in the SQL client here that implement that contract. Because that to comply to the fact that it needs to return domain objects. So then if you need to change one database technology to another, moving to MongoDB, for example, you just have to add here a new module implementing that interface without having to change the domain and neither the controller on the other side. So it's a more plug-and-play architecture. We call that also ports and adapters. And the API and SPIs here are the ports on which adapters are connected. And we call them adapters because they are here to adapt the outside world, meaning REST or SQL, into the inner world of the domain. But enough talking. It's now time to see how all those things can be implemented, and we'll do a little live code here. So I've prepared the application, and let's say we're at the really beginning of the project. You have to know that in Hexagonal Architecture, we always start by writing the business logic, because this is the main important thing. But you do that feature by feature. So first, business logic of the feature, then the controller, then the persistence layer, or the other layer if you have, and then you move to the other feature. And here we're at the very beginning, so that's why here I only have one Maven module. Is that big enough? Yes? And that Maven module represents the domain. For now, the first feature is not yet implemented. But you will see here in the POM XML file, there is no mention at all on the Spring Boot. Here I have JUnit, assert J, because I need that for the test. In the domain, what do we have? I have here represented the domain model. So this is the domain object. Here, a fleet is a record of Starship. And a Starship is something that has a name, and a capacity has an integer. Now we have to develop our feature. But you have to understand that today, Hexagonal Architecture is more than just an architectural pattern. This is also an approach in which we will shape the contract of the domain by writing first a functional test. So we'll do what we call the acceptance test-driven development. So we have here a functional test, which is quite simple. It wants to assemble a fleet for 1,050 passengers. So given that number of passengers, when I will here create the fleet, this is the code we'll have to change, we'll make sure then that all the starships of that fleet has altogether enough capacity to rescue all the survivors, passengers we need to rescue. And we also make sure that each of these starships has capacity, meaning more than 0. OK? So let's implement here our feature. So I would like my production code to look like something like that. Assemble a fleet, 4 passengers given a number of passengers. OK, so assemble a fleet does not exist yet. So let's create that. And here, local variable, I have to give that a type because this is a real language, right? So assemble a fleet. OK. Oh, no, not that. Like that, please. We'll initiate that to null for now. And OK, let's move that here. So assemble a fleet type does not exist. Let's create that. And IntelliJ is asking me if I want here to create it as a class or interface. What should I use? Louder, I cannot hear you. Interface, right. Because in fact, this is a contract to interact with the domain. So I put that in the production code. And in which part of the domain I will put this interface? API, you got it right. So if you don't like the name API, you can use here instead feature. It's quite the same thing. OK, so we created the here interface, and then let's populate it with the contract. We'll infer that from what I've written here. OK, so we have the 4-passenger method, and you can see it depends only on basic types of Java with the integer, or the fleets that come from my domain, to avoid any pollution from the left side. OK. So to be able to execute that class, here I need to provide an instance, a concrete implementation. We call that fleet assembler. And let's create that. So obviously it will be a class. We put that in the production code. And yeah, also it has to comply with the assemble a fleet contract, because this is the concrete implementation of the contract here. OK. So here, we will write our business logic. So let's do so. You will see I'm a pretty quick developer. And there is 2 phases here in that business logic. First, we will retrieve the starships from the external repository Swappy. And then our AI model that will assemble a fleet with the starships and according to the number of passengers we have to rescue. So let's create all those things. So first, let's retrieve the spaceships from Swappy. Remember, Swappy is an external product. This is a web service. So if I need to call a web service, what should I do? Yeah, you're right. But I mean, in the implementation, I need to do HTTP calls, right? And I cannot put HTTP calls here, because that's technical details. If I'm moving Swappy from something else and my inventory becomes a file, I will have to change the domain, right? And even though you say, OK, I'm moving from one web service to the other, it's quite sure that the REST API will be different. So that's why in the Hexagonal architecture, you cannot do here HTTP calls. Instead, the only thing you can do is to create an abstraction of your external partner, and we call that here Starship Inventory, and I would like it to have a Starships method to retrieve all the starships. So Starship Inventory does not exist. Let's create it as a field here, give that a type, Starship Inventory, OK. And it doesn't exist, so let's create that. Class interface. Interface, yes, because this is a contract to interact with the outside of the domain. So which subpart of the domain where I will put that interface? SPI. OK. So it's there. And then here, I will create the contract. So you can see that it depends only on Starship from the domain. So here, we have built the barrier on the right side. And our domain is now contained. OK, so I have to do a little trick there because I want to filter out the Starship that doesn't have enough capacity. And now come the time, the moment you're all waiting for, the implementation of that AI model. So don't worry, don't be too hard with yourself. You won't understand what I will write, but it's totally okay. And I'm also proposing you to not read at the code, otherwise your brain will blow. Okay, don't write at the code, I said. Don't read the code, sorry. Okay, I lied, this is not AI, there's not 3 ifs. But I have a while, right? So it's better in a way. But it's not the main purpose here. I mean, it's a naive implementation where I'm taking one ship after the other until I have enough ship to transport anyone. But we are here more about the hexagonal architectures and that business logic. So for now, the business logic is implemented, but we need an instance of that Starship inventory, right? So the concrete implementation of that will be my Swappy client. Swappy is the name of the inventory. I cannot put it here. I cannot instantiate that here because this is technical. It will be in the infrastructural part. So we'll do something that you may know, which is called the dependency injection, okay? And we'll do an injection through the constructor, sorry. Okay, so I have one problem here, and this is because I need here an instance of that Starship inventory to be able to execute my functional test. And even inside a test, you are not allowed to have the technical dependency for the domain because you want that to be portable as much as possible. So the only thing you can do here is to create a stub. So I will here inline a fake referential of starships, making sure I have a bunch of starships from something that cannot transport any passenger or really big starship. And I will simply pass that here, thanks to Java 7 as a lambda, okay? And that will be my anonymous implementation of a Starship inventory. So this is fake data, but this is totally fine because here, what you want to test is the business logic. You don't care if the data is real or not. Because that, we will test it later in an integration test. Okay, so let's see here if this is working now. Let's execute that business logic. Hopefully, the test will be green. Yeah, that's green. OK, so here you can see the content of my Starship, my rescue fleet. OK, so what we have seen so far, we have created a functional test to shape the contract of our domain. That contract is here, the assemble of fleet. It depends only on domain objects, so nothing from the left side can contaminate that domain. The concrete implementation, the real feature, is fleet assembler here. We need data from outside. Since it cannot have a direct dependency, we have created a Starship inventory interface in the SPI that also depends on domain object only. So we created our barriers to protect the domain. And then we created here a stub to be able to execute and test that business logic. So the business logic is created, and then what we do, we will expose that in a controller to have the first feedbacks from our consumers. So let's do that. I will just do a little fast forward to avoid any boilerplates. And now you should see that there is a new Maven module, the infrastructure in which I will put the controller. Obviously, that infrastructure here depends on Spring Boot, making sense because frameworks such as Spring Boot are made to make your life easier with mandatory complexity. On the other side, in the domain here, I've protected it a bit more. With the enforcer plugin of Maven and the ban dependencies here, I'm excluding everything. So I'm a bit drastic. You can do some fine-tunings here. But if I'm adding by mistake something, framework or the infrastructure of my own application, the Maven build will fail, right? If you don't like having here multi-Maven modules projects, you can use instead packages and achieve the same kind of checks than the enforcer plugin with ArcUnit, if you know it. But I won't show you ArcUnit because I don't have time to. And obviously, in the infrastructure, you can see the domain. It should be there. OK. OK, so now let's try to implement the controller. But even in the infrastructure, I won't start by writing the controller. I will write an integration test first. So let's do some ITDD. So here, we have the REST controller tests, and I will shape that way the REST API. I'm expecting to be able to do a post on the URL rescue fleet here with a content type set to JSON, and I would like a request, which is a JSON with a number of passengers. And here I put 5 for the test. And I'm expecting, as a return, as a response, to have a status 201 created, HTTP, and inside it, I would like a JSON in the content that has an ID, which should not be empty, a list of starships, and should have only one element. That should be the Millennium Falcon with a 6-passenger capacity. So this is the contract, the REST API contract. OK, so now let's here implement my controller. Here you can see that has been mapped on the rescue fleet URL. And here this is the post mapping. So basically, this is the route that we need to implement here. So we are inside the controller. So what should I call here? Any idea? Sorry? API. Exactly. So here, I will call the API of my domain. So it's exactly the same thing, the assemble of fleet for passengers, given that number of passengers. The number of passengers here will be given to me thanks to Spring Boot, because it will serialize the request with the request body here annotation into that class. And here you can see that I have my number of passengers. So let's retrieve that number from the REST request here. OK. Here, assemble of fleet does not exist, so we create that as a field. It asks me if I want to import it through the fleet assembler, the concrete implementation, or the interface. On that side, and only on that side, you can get rid of the interface if you want, if you don't like having too many of them. It's not a big deal if your controller knows exactly your domain. But I also like to have here interfaces, because that way I will be able to stop the domain in my controller for tests without having to rely on external testing frameworks such as Mockito. Because since Java 7 and functional interfaces and Lambda, it's easier to write that kind of mock. But anyway. So here, I need here to have someone that will give me an instance of assemble of fleet, and we'll see later how it works. You can see that it doesn't compile because my domain is returning a fleet, while my controller expecting me to return a response entity of that fleet. If you don't know response entity, this is a wrapper, an abstraction created by Spring that represents an HTTP response in which you can set yourself, headers, HTTP status, content, and so on and so on. So this is purely technical and Spring dependent, so I don't want that to be inside the domain. So here, I have to do my first adaptation. I'm adapting the domain into the REST stuff here, technical stuff. So I will wrap what the domain is returning here inside a fleet, and then I will create a response entity out of it. So here, it should be this one. I'm simply using some Spring factory methods. Here, created will automatically create a response entity 201. And you can, so this is the location header, but I just put empty. Don't do that in production. Put a real location header. And here, I'm just passing the fleet in the body of that response entity. OK, so now it's compiling. But as you can see here, I have one error. IntelliJ is able to understand that I won't be able to inject a concrete implementation of my fleet assembler in the controller here, because no bin, Spring bin, exists in the Spring context according to that type. So what we do when we want to fix that problem? Usually, we go to the concrete implementation, and we put here some kind of annotation like component or at service, right? But can I do that here? No, because those annotations belongs to Spring, and my fleet assembler here belongs to my domain, so I cannot do that. So instead of doing that, what people do actually, usually, inside the infrastructure, they create a configuration like this one, and they do some bin factories, as you may know, like that. So they instantiate their object of the domain, and then they annotate that kind of method with @bin, so it will be registered in the Spring context. But I don't like this option either, in fact, because it's like doing half of the job of the dependency injection framework, right? So let's get rid of all those things here, and let's clean that up. I rather like to rely on annotations because for me it's a better developer experience. But the thing is that we cannot do it in a way that the domain knows Spring. But we can do the opposite. There is a little trick that will make Spring aware about the domain. And this is quite easy to set up and to do. In my domain here, I've created my own annotations. Usually I'm doing that to do some living documentations. But here, it has also the purpose to be able to be scanned by Spring. Here, a domain service, if you don't know domain-driven design, is exactly the same thing as a feature. But what is interesting here is the fact that I have retention policy set to runtime. So Spring should be able to scan that annotation. And then here, on my fleet assembler, I will simply add this annotation. But Spring is still not aware about this annotation. So what we have to do then is in one configuration, we'll add here a component scan directive in which we'll say to Spring, scan for everything annotated by my custom annotation. And now this is Spring knowing the domain and not the opposite. And it works because if you go here back to the controller, the error disappeared. And even IntelliJ is able to find, if I click in here, which bin will be injected from the domain. But we still need here an implementation of Starship inventory. So you have two options. Creating the swapping client in the infrastructure, or you can do something else. You can do what I will do here. I will create a stub of it. And I will explain you why it can be an option for you. So creating a stub of Starship inventory, if you remember, I've created one already in the test of the domain, right? It was my lambda, remember? I just wrap it here in a class, which is Starship inventory stub. And that stub here belongs to the domain in the production code. I will explain later why. Here, I have my referential back, and obviously it has to comply with the Starship inventory contract. So I would like this to be used by Spring as well. So same story, you create your own annotation. Here, this is stub. I'm annotating that class with here at stub. And you know what comes next. We are going back to the configuration here. And we ask Spring to scan for everything annotated with stub. And now, if I'm executing the test of the controller here, hopefully it will work. Let's cross fingers, because you never know with Spring, right? Red, no, it's normal errors. Everyone has normal errors, right? The test is green, so it's OK. Yeah, I don't know how to get rid of these warnings, but anyway. But it works. So what's the point of having that stub in the domain? In fact, now my application is working. I can deploy it in a pre-production environment, for example. So let's start it. And that way, your consumers can try to play with it. Here, I will do a request for 800 passengers. And you see, it works. Even though this is fake data, I'm testing the business logic. This is something I applied when I was working at Expedia. We had a really shitty backend. And we had to do evolution. It was a nightmare. So we decided to recode it from scratch. But at the same time, the mobile teams were about to integrate that backend in their application. So we passed a deal with them. We said we'll write the business logic feature by feature with fake data and expose that in the controller. We deploy the application for you, and then you can start to play with it, understand what is the business concept, the workflows, and so on. And this is real business logic. So they give us feedbacks, and we're able to parallelize the work in a way that integrating the inventory of trains, because it was a train ticket service, took us 1.5 months for the full team. We were 5 developers. They didn't have to wait for everything, right? They didn't care that data was fake. They were able to start implementing stuff. If you don't have that kind of need, okay, you can put the stub in the test inside the application. You don't have to do what I have done here. But just to show you that you can be a bit more incremental with the Hexagonal architecture, because everything has been built to be stubbed if you need. OK. So to sum up what we have seen so far, here we created an integration test that the aim was to define the REST API. Then we created the controller, which is exactly at the same place than the functional test. So it has to call here the API of the domain. And because all the things I just explained, I put the stub in the domain, in the production code, but you don't have to if you don't have the need. So for now, this is fake data. So obviously, we won't live long on that, and we need to create our Swappy client. But first, I would like to show you what is Swappy. So this is an existing API, if it may. OK. It's coming. OK, so yeah. So this is an existing API, totally free, available on the internet at swappy.dev. And this is a referential about everything about Star Wars. And here, I'm using their endpoint, Starships, like it was my external inventory. And we will integrate that in our application. OK, so let's proceed here. So let's do a little fast forward again, because here, as you can see now, I have one new package in the infrastructure named Swappy, in which I will have my Swappy client. But what I will do before implementing it, a test. Yeah, you don't like tests, guys, or what? Yeah, I will do here, an integration test. Here, as you can see, I would like to be able to call my Swappy clients. And when I will call Starships, I would like to get these Starships. But remember, Starship is an existing web service, an external web service. So I don't want to rely on that in my CI/CD. Otherwise, it can be really flaky. So what we do in that case, we create a mock server here. So I'm using the mock server of Spring Boot. And here, I'm simulating in the test the real Swappy. So I reproduce the Swappy contract here, able to do a get on that URL, returning a JSON, and I've extracted one Swappy response. And I put that in one JSON file that will be served for my own application for that test. And I will show you the Swappy response, because this is quite interesting. What do you notice here first? There's something really interesting at the beginning. What do you see? No? No one see it? It's paginated, right? I didn't expect that first. OK. Let's see how we will deal with that. Then the Starships here are named results. I don't like it. But anyway, this is their choice. There's a lot of things about Starships, but I only care about name. And here, passengers, which is the passenger's capacity. But there's something really annoying here. Can you see it? This is a string. I should sum the things, right, for my algorithm, so it's annoying. But we'll see how we deal with that. OK, so let's implement our Swappy client. So here, obviously, it has to comply with the Starship inventory contract. So we have here the Starship method. But what is interesting here is that we need to get all the Starship at once and give that back to the domain. The domain don't care if you're paginated or not, right? It's not his concern. So it means that locally, we'll have to deal with the pagination. With that Hexagonal architecture, usually I see people, when they have a paginated partner, they become as well paginated. You know, like it was a contamination, right? This is paginated and paginated. They move something else that is not paginated. Oh, what should I do? So here with the hexagonal architecture, you will put that in the adapter, which is making sense, because if you move to something else which is not paginated, you don't have to change your business logic for that. Your business logic should be paginated because you know functionally that you need it for your own application. And in my case, I know that there is not a lot of, let's say, a lot of Starship I will return, so I don't need pagination. So here, I've written the paginated client, initiating the next page URL to that URL, which is the first Starship's endpoint of Swappy. And until the next page is not null, I'm retrieving the spaceship from Swappy, and then I'm collecting all the responses in that list, so I can return that at once for the domain, and I'm moving to the next page. OK, so let's proceed. Getting Starship from Swappy is quite easy. Here, oh, sorry. So getting the Swappy Starships here is quite easy. You only have to do a REST template, doing a get on the URL, and serialize it here in the Swappy response. And the Swappy response here is quite interesting, because here we have the next page, which is a string. The results, remember, this is the starships of Swappy. And a Swappy starship is something that has a name as a string and passengers as a string. While in the domain, when I made the conception of that, you can see that for the starship, we have a capacity as an int, which makes sense. I want to sum these values, right? So it means that here, sorry, I have to go back to the client. It means that here we have to do that conversion. This is the choice of Swappy to use a string, right? And I don't want that string to go inside the domain. Otherwise, my domain, we have to do some kind of defensive code, making sure, OK, is that empty? Is there any characters that I cannot map? OK? And this is because of Swappy. If I'm moving to something else that has a big decimal, I don't want to change my business logic. You understand the philosophy? So here, that's why we'll do that conversion only in the Swappy client. So let's proceed. Here, for all the results of that Swappy client, I'm creating a starship, and I'm taking as it the name of the Swappy starship, and the passengers of the Swappy starship, I'm passing it as an integer. This is clearly an adaptation, right? OK, so then here, if I execute the test, do you think it will work or not? Any guess? Yes. Yeah, you believe in me. Thank you very much. But you should not have to. Because why? Here, this is a normal error, because I knew it will come. Here, you can see that sometimes on the passenger value, I have NA. Oh, NA. That cannot be parsed as an integer, right? And if we take a deeper look here in the Swappy response, yes, sometimes we have NA, and sometimes we have a known. A known, OK? So it means that we don't have a good data consistency in Swappy. Not good. And we have to deal with it. And furthermore, if you go to the next page there, you can see that sometimes we have 1,000 separators. OK, so it looks like Swappy was more made for UI than for another backend. So it might not be the better choice. So maybe I will get rid of that after I have integrated it. But thanks to the hexagonal architecture, it will be easier to get rid of that. So here, what is really important is that all those things regarding data inconsistency, it's not your domain that has to deal with it. This is a problem of Swappy, right? It doesn't have to come inside your business logic. So we'll do here everything to make sure that what you return to the domain will be always valid. So here, we'll do a little filter, making sure that all Swappy Starship has a valid passenger's value. And having a valid passenger's value means you are not NA or unknown. And then here, I had to get rid of the 1,000 separator. And I've asked my master, who gave me a really nice way to do that. He said, I simply have to replace all comma to empty string, and it should work, right? OK, so I think you have guessed who my master is. This is ChatGPT. So don't do it yourself in production. I'm a professional prompt engineer, so I'm allowed to do that. OK, so here, if that time I'm executing my Swappy client test, hopefully it should work. And that time it should work. OK? Yeah, it's working. So we have dealt with all the data inconsistencies of Swappy. And this is really important, because here, your partner will make its own design choice. It doesn't have to pollute you, right? You have to think about what you need and then adapt with what your partner is doing. So that's why here we have that Swappy Starship. And this is also something that we call an anti-corruption layer, because you don't map just as it. You get rid of all the data inconsistency. You cannot map that because passengers is set to unknown. You get rid of that, because everything in the domain is always valid. OK? OK, then. Let's say we put that in production. This is working fine. But we discovered that our survivors has to leave away all the materials they have, because we didn't think about the fact that the ships should have cargo capacities. So we did here a little evolution. And now if we go back to the Starship of the domain, no, didn't work. It's coming, perhaps? Yeah. Here now you see we have cargo capacity. But there's something which annoys me here. Capacity, cargo capacity. Don't like that. Let's do some renaming here. Here, let's call that passengers capacity. It's better. So maybe you're wondering why at the really end of the talk I'm doing some renaming. Because I can, yeah. Do you know what's the impact of that on the application? Any idea? Any guess? No? I just broke my consumers. Really? Why? I will show you. Here, let's go back to the controller test. If I'm executing that test back here, you will see that it no longer works. OK, so let's see what's going on. And this one is not a normal error. Here you can see that the test was expecting to have a capacity, while here I have a passenger capacity because of that renaming, right? So I just broke the consumers. So this is just because in the controller here, I'm serializing as it the domain object. So if I'm doing some changes in the domain object, my consumer gets impacted. So it means what? It means that here I need to do some REST versioning, REST deprecation in the domain itself. Nightmare, right? Because I would like, I have some trouble with the API, but it's not the matter of the business logic. So here, what is missing is, in fact, a representation of the REST resource. And by magic, here it is. I'm so fast. I didn't change at all the branch, right? You didn't see that coming. But anyway, so here I have now a fleet resource. That fleet resource belongs here to the controller. This is the representation, the REST representation of what is a fleet. And here it has an ID, a Starship resource. And a Starship resource here, you can see that I have capacity and passengers capacity, the old and the new field. So that way I'm backward compatible. I can say to my consumers, be aware, that capacity here will disappear someday. But here on the domain, you see I'm mapping twice passengers capacity of the domain, once in the capacity of the Starship resource, and then in the passenger capacity of that resource. In the domain, it means that it's still clean, right? I don't have capacity anymore. So I can do my REST versioning now in the REST controller. I'm telling that because sometimes people do that mistakes, and when it happens, it gets messy. So here, you can see that now with the Starship resource and the fleet resource, that are the image of those things in the domain, we have created our anti-corruption layer as well, because we decouple the consumer from the implementation of your domain. So this is the big picture. I didn't show you also the integration test for the full application. But this is all the things that's working, in fact. But if you want to see the code, it's possible because you can scan that QR code to have access to the repository. My name is Julien Topçu. I'm a technical coach at Shodo, a consultancy company specialized in domain-driven design and software craftsmanship. And if you have any question, don't hesitate to reach me after the talk. Thank you very much.